Every human body writes a rough timeline after death, and scientists can read it. Detectives use that timeline to help solve real mysteries. But that timeline isn't a stopwatch, it's something stranger. Even your own cells keep working for a while after you're gone. And scientists still can't agree on when your brain truly goes dark. New research even suggests brain activity can flicker back during CPR. This isn't science fiction. It's an active, unresolved scientific debate. Let's follow the body's real timeline, hour by blurry hour. The first clock, body temperature, starts drifting toward room temperature. Investigators use a rough rule of thumb, about 1.5 degrees Fahrenheit an hour. But it's a rough estimate, never a precise timer. Cooling barely happens at first, sitting on a strange plateau for hours. Past about 12 hours, the temperature clue gets unreliable fast. Room heat, body size, even clothing all throw the estimate off. Even forensic science's best cooling model only gives a range, not a moment. Every temperature clue is a rule of thumb, never an exact law. The second clock, gravity pulls blood toward the body's lowest points. A faint discoloration can appear within 30 minutes to 2 hours. For the first several hours, that pattern can still shift if the body moves. Eventually, roughly within 6 to 12 hours, the pattern locks in place. Investigators check whether that locked pattern matches where a body was found. A mismatch can hint the body was moved after death. Even this clue is a wide window, not a precise hour. 2 clocks down, and neither one ticks like a real watch. The third clock. Muscles slowly stiffen as their energy supply runs out. Stiffening often starts small, in the eyelids, jaw, and neck first. It then spreads outward to the larger muscles over the next few hours. Stiffness generally peaks somewhere around half a day after death, roughly. After that, the stiffness fades again within 1 to 3 days. Body temperature, muscle mass, even cause of death change the speed. None of these 3 clocks tick at a fixed, guaranteed pace. So what does that mean for figuring out exactly when someone died? Here's your turn to guess before the real answer. Pause for a second and think about your answer. Roughly how long does an average body take to fully stiffen up? A few hours? Half a day? A full day? Lock in your guess before the reveal. Here's the catch. There isn't one single right number. Peak stiffness can land anywhere from about 6 to 24 hours. A warm room speeds it up, a cold one slows it way down. Even trained forensic scientists describe it as roughly, never exactly. That wide, honest range is the real answer, not a clean number. Meanwhile, a fourth clock starts quietly inside every single cell. Without blood flow, cells begin quietly digesting their own insides. Enzymes normally kept sealed away leak out and break tissue down. One early visible sign can be a faint clouding in the eyes. Around the same time, bacteria join in from the inside out. That bacterial process is what eventually causes the classic odors of decay. Forensic science sorts what follows into 5 broad stages overall. Stage 1, fresh, is just those first clocks quietly ticking away. Stage 2, bloat, is driven by gases building up from bacteria. That stage alone can start anywhere from about 3 to 5 days, roughly. Heat speeds every later stage up, cold slows it dramatically down. The remaining stages vary so much. Scientists won't pin them to fixed days. The 5th clock is the strangest, and it's still genuinely unsettled. The classic textbook answer: brain damage begins within about 4 to 6 minutes. Measurable brain activity is commonly said to flatline within about 15 seconds. But newer resuscitation research is actively challenging that simple picture. One major study found brain activity can flicker back during CPR. In some patients, that activity returned at points up to about an hour later. That doesn't prove awareness returned. The same study found no clear link. Scientists still genuinely disagree on what that flickering activity even means. So the body runs on a blurry checklist, never a precise stopwatch. There's a whole map of curious questions waiting at hello Curioo.com.